Welcome everybody, here we are, Lesson App 2.4 homework, the video coming at you to help you out. This is about refrigerators and how much capacity they have in cubic feet. We're going to make a histogram of all of this data. So go ahead, open your applet. Let's use one quantitative variable, call it fridge space with a P. I don't want to type all the data in, so I'm going to take a screenshot. Boop. Then you should be able to just highlight all the numbers, copy them. Pretty slick trick. And paste them in here. Now, there you go. Now, sometimes they don't translate perfectly. So if I hit begin analysis, this has been happening to me. I see that dot way out there all by itself, like 180. So I got to find that dot, and I think it's way out in the 17. So here's the only way I know how. I'm going to put my cursor there and start hitting space bar, and then boom, this is the only way I know how to get over there. So if some of you know a better way, let me know. And then I'm going to hit over here, hit space bar a couple times. There's got to be a better way. So someone who's listening, please tell me in class. 16.3, gonna keep going. I'll get there soon, but this is still better than typing in every darn number. So, aha, I found it. You see it right there? 17.9. Okay. It'll say, you sure? I'm like, yeah, I just modified it. So there we go. Begin analysis. Let's do the histogram. That's what it asked me for. And there you go. So let's just take a screenshot of this bad boy. Put her in there. You might as well just leave the summary statistics. Why not? Um, and go back to the lesson. And let's put it in there. Okay. All right. Just put there. That we can do better if I. All right. And then describe the shape. Well, I would say that looks pretty much symmetric. I don't know if you agree, but I'd say so. So I would say roughly symmetric. To me, it looks single peaked as well. To be approximately normal, it should be single peaked. And I would say somewhat bell-shaped. So there we go. Number 2, let's use these summary statistics. Well, I guess I took a screenshot of them. There they are. To find the percent of data values that are within 1, 2, and 3 standard deviations of the mean. How closely do the results match the empirical rule? Ah, yes. So the empirical rule, in case you forgot, I have a sketch down here. It's this. It's the 68, 95, 99.7 rule within 1, 2, and 3 standard deviations of the mean. So, you gotta do a little math here. What is the mean plus or minus one standard deviation? So the mean in that table there is 15.85825 plus or minus one standard deviation of 1.217. I'm going to try to be smarter here. So then I'm going to copy this. Ooh, not that. And paste it 3 times for my calculations. Okay. The only thing that's going to change is how many standard deviations. So 2 and 3. Then you can watch me do these calculations. You can do them yourself. It's totally up to you. 15.825 plus 1 times 1.217 is 17. Oh, here I did the large number first, didn't I? So to 17.042. What's the smaller number? That would be when you subtract. So there, 14.608. And I got to do this for the rest. So what if I went down 2 standard deviations? I got 13.391 up to, just using that feature to try to speed up my calculations, up to 18.259. Last one, 3 standard deviations. Let's do the lower one first. 12.174 to 19.476. Okay. So then I've got to try to go through the data, counting first how many data points are in between here and here. Okay. I wonder if I could use this to help me with that. I'm going to try that. If I go back to a dot plot, no, that's not specific enough. I'm just going to go back to the data, I guess. So how many are in between 14.6 and 17.042? And let's just highlight them. Let's make them blue. So they're in order at least. So 14.608 starts right here, and it goes all the way to, this is most of the data, isn't it? To right there. So how many did I just count out? I believe if you count those up, you're going to get 24. Okay. So that is 24 out of 36, because it says right here we have 36 data points. And seeing is believing. What is that percentage? 24 divided by 36. Well, that's 2/3. So that's 66%. 0.6 repeating. Okay. And then how about the next chunk is going to add on some more. We're going to go from 13.391, which goes all the way down to adding these red ones in addition to the blue ones. And it goes up to 18.259. So it gets those. So I'm adding on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 onto the 24. So that would be 34 out of 36. Okay, which is 94%. Okay, and lastly, how many are within the last standard deviation? Let's go yellow. 12.1, so that is above 12. That works, and that works. So adding in the last two brings me to all the data. That's 36 out of 36, which is 100% of the data is within 3 standard deviations. So, number 3, based on our answers to questions 1 and 2, is the distribution of capacities of refrigerators approximately normal? And we would say yes. Okay, because yes, the percentages we just found match the empirical rule very well. The percentages, I will say it this way, are very close to the 68%, 95%, and 99.7%. Those are our targets for a normal distribution. So it's pretty good evidence. Okay. Also, the graph itself, the graphical evidence is also very strong. Because the shape was single peaked, like we talked about up here, single peaked, symmetric, and bell-shaped. Okay. All right, 4 and 5. Assume the population distribution of usable capacity in refrigerators is normal with a mean of 16 cubic feet and a standard deviation of 1.2. So we're leaving this behind. Okay, that is no more. We're starting fresh. About what proportion of side-by-side refrigerators have a usable capacity between 13.6 and 19.6? So what I've done here is I've copied some of these off of the notes from the lesson to help us with this. So I'm going to label my normal curve with this information, both of them, okay? So we've got 16, and then the standard deviation is 1.2. So you can use your calculator to help you, but that would go 17.2, 18.4, 19.6. Going down, I would have 14.8, 13.6, and 12.4. I'm going to just move those, copy those over to this one over here. I guess I'm going to use both these, I think. Okay. All right, so what percentage are between 13.6, it says, and 19.6? Whoa, hey, look at that. That's this one and this one. So what percentage is there? So you might just look at these and you can add these up and you'd have your answer. Piece of cake if you remember those, okay? So what am I working with there? Whoa, fine. Too much, too fast. Um, that's what I wanted right there. Okay, so I wanted from here to here. So 13.5 plus 34 plus 34 plus 13.5. Well, hey, that's the 95%. If I stop right there, I could have known that, right? That's 2 standard deviations. That's 95%. And then I just add the 2.5 on. Oh, that's not so bad, huh? Ain't so bad. Oh, you know what though? I think I didn't do this correctly. Sorry. Those aren't 2.5. They're not. Oh, no, no. Okay. Because from here, oh, fine. From here to here is 95%, right? As shown right here. So the from here all the way out and from here all the way out makes 5%. Oh, shaboodoo. So if I have 99.7 minus 95, that means that these two blue sections make 4.7% combined. So each one of them would be 2.35. That's pretty technical, but it could come down to that if at the end of the day. So then here, let's add a new color in here. Purple. Well, it won't let me do that right now. All right, we'll do hot pink. So these hot pink sections, well, what's 100 minus 99.7? Well, it's 0.3. Cut that in half. Each little hot pink section out there is 0.15%. So it's tiny, but it is there. All right, so now, sorry, back to the original question. Number 4, percent of fridges between 13.6 and 19.6. So if I zoom in there, right, from here to here is 95, and then I'm adding 2.35. So 95 plus 2.35 is 97.35. Okay. Whew, sorry, that took a while, 97.35%. Well, it already took a long time. Let's take a little bit longer. You can do this on the applet. Remember this? So let's go back to my menu and do the normal distribution right there. Put in the mean that they gave us, which was 16. Put in the standard deviation, which was 1.2. And then plot it. There it is. That matches what we had. Our lower boundary was 13.6. Oh boy, it must be getting late. I'm so tired. 13.6. Fag. Fat fingers. Okay, all right. How do I get that to not 13.6? Oh, finally I did it. I'm going up to 19.6. And calculate the area. So there it is, 97.5. It's a little bit more precise with that extra 9 at the end. And it shaded it for you. See that little sliver on the far right? That's that 0.15% sliver. Last question. All right. Find and interpret the 16th percentile of the distribution? Let me show you this. This is cool. If you didn't know in the applet, you can do this and you can calculate the value corresponding to an area. So you can do a left tail or a right tail. So if I do a left tail of 16%, so 0.16. And there it is. Oh, look at that. It's exactly on 14.8. So that is my answer, is 14.8. But if you didn't want to use your calculator, here's how you do that. So 84% is the combined with 16% makes 100, right? Why did I pick 84? Because as I look at this, I've done this enough to know that this practice makes perfect. That is 50%, right? Let's do that. So this entire half, that's 50. And then plus 34, 50 plus 34 is 84. Okay, meaning that from here up is 84% of the data, which means from this blue line down must be 16% of the data, which is the 16th percentile. So there you go, folks. Thanks for listening. Hit that subscribe button.